All right, hey everyone, this is a quick video to run through some of the main ideas from our weather unit. So we'll start off with some quick resources. I've attached this slide to your most recent post in Canvas and Classroom. So any hyperlink you see in this slide, you can click on and explore for yourself. First, I've attached a link to the week 1 guide, which outlines your first assignments and some resources to explore weather on your own. Second, I've attached slides for week 1, as well as this slide deck I'm about to go through with you. Third, I've attached a link to the YouTube channel where this video and others are already posted. And finally, if you want to get in touch with me, I've attached links on how to use Remind and my email address in case you need to send me a message directly. So for week 2, what you need to be working on is your weather tracker. For the next few days, you're going to be exploring the weather on an app, outside for yourself, or on TV, and recording different aspects of weather that we're going to learn about, like temperature, pressure, precipitation, and some more things. Make sure on your copy you list your name so I can know who turned in your work. And as you're tracking the weather over the course of about a week, make sure you're looking for some different weather patterns. How does the weather change day to day and several days at a time? The links on the sides will take you directly to Google Classroom where you can fill out and turn in your own work. So in this packet, in this entire unit, we have one giant question, one big question. How are weather conditions created? That's the whole question that we're going to explore as we learn more about weather. So in our first week, in the first section of the packet, we learned several things. They're listed here. First, we observed weather. We used our senses to notice what's going on outside. Then we talked about the difference between weather and climate, temperature, atmospheric pressure, wind, humidity, precipitation, air masses and fronts, and finally, predicting weather. So what we're going to do is go over those ideas in this video, starting with observation. Scientists make observation using our senses. Making observations helps us better understand our world. If we think back to the beginning of our time together in science class, we talked about how we use our sense of sight, smell, taste, sometimes, touch, and hearing to understand what's happening in the world around us. Using those senses is how we understand what's happening, what's changing, and we can also use those senses to predict what might happen next. Now, weather versus climate. Remember, these things are different. Weather is what's happening in the atmosphere in a specific moment. Climate, on the other hand, is the average weather of a certain place or area. In other words, weather is what you get, but climate is what you expect. Another way to think about this is weather is what's happening outside right this second. So examples of weather would be it's raining outside right now, or it's sunny and a little windy outside right now, or there's a tornado outside right now. Weather is what's happening in a specific moment. Climate is a little bit different. Climate is the average of all those moments in weather. So if you look at the GIF on the left, we can see temperature in our planet. We can see the cooler temperatures near the poles because normally it's colder. Similarly, when we look at the equator, we can see those higher temperatures because normally, or on average, it's warmer there. We can look at climate or average weather conditions on the global scale or in a smaller way. On the right, there's a picture of the United States. We can look at climate for a certain state or region as well. Reminder, weather is what you get and climate is what you expect. Next, let's talk about temperature. Temperature is a measure of heat energy. 2 units for temperature are Celsius and Fahrenheit. Many countries and most scientists use the Celsius system. Celsius is based on water. Freezing water is 0 degrees Celsius and boiling water is 100 degrees Celsius. If you want to learn more about the history and formation of the Celsius system, check out this video I've linked in the slides. Next, atmospheric pressure. Atmospheric or barometric pressure is the weight of the atmosphere above us. So, changes in pressure usually will signal a change in weather is coming. We have high pressure systems and low pressure systems. To give you a visual of what air pressure kind of looks like, I've attached this picture on the left. If we think about ourselves on Earth, there's a lot of air, a lot of atmosphere above us. All this air and all of this atmosphere has weight. The weight of that air is air pressure. The picture on the right shows the relationship between air pressure and altitude, or how close or far away you are from the Earth's surface. So, at very, very high altitudes, far away from the Earth's surface, we can see that there's low atmospheric pressure if you check your x-axis. As we move down, as we get closer to Earth's surface, or a smaller, lower altitude, we can see how the atmospheric pressure increases. And this makes sense. The closer we are to Earth's surface, the more atmosphere is above us. And as a result, more air pressure or more weight is pushing down on us. Now, when we talk about high and low pressure, we mentioned that there can be a change in weather coming. Now, with high and low pressure, there are different kinds of weather we can expect. So if you look at this picture, side A shows a high pressure system. What this means is there is a lot of air. A lot of air molecules are packed into the same place. What happens when we have lots of air molecules packed in the same place is they want to spread out. Those molecules try to get more space, and as a result, they move away or move out from the high pressure system. When this happens, air is brought down from higher in the atmosphere, and when this happens, we can expect normally clear, calm skies. A quick way to remember this is high pressure brings happy weather, not very many storms happening. On the other side, we can have a low pressure system. In a low pressure system, the exact opposite is happening. When there's low pressure, there are not many air molecules in a certain area. And as a result, lots of air molecules move in and try to fill that space. When that happens, all of those air molecules meet in the middle and they are pushed up into the atmosphere. When that happens, the air molecules begin to cool down and the moisture in that air will begin to condense. This causes storms and clouds and precipitation. So a quick way to remember what happens in a low pressure system is low pressure brings lousy weather. Think rain and storms. Again, here's a different picture of what happens in a high and a low pressure system. High pressure, air tall, high in the atmosphere moves down and out. This brings sunshine or happy weather. The opposite is true in a low pressure system. The low pressure means that air molecules move towards the center and they move up. They rise in the atmosphere, and when they do that, those air molecules and water molecules will condense, causing clouds and precipitation. Again, high pressure, happy weather, low pressure, lousy weather. The movement of air in the atmosphere is called wind, and this is caused by differences in temperature and atmospheric pressure. When we think about pressure in the atmosphere, we can think back towards the very beginning of our school year where we talked about density. If you look at this picture, this left square has high density because we have lots of particles, or molecules in this case, packed into one square. The square on the right is low density because the same amount of space has much fewer particles or molecules. To connect this to wind, when there's an area of the atmosphere with high density, lots of air is packed in, it wants to spread out, it wants to expand. And when that happens, the molecules will find areas of low density or low pressure so they can spread out and take up more space. The jet stream is a great example of wind at a really large scale. This GIF shows wind moving across the northern hemisphere in the polar jet stream. The yellow and red show faster moving air. We can see how this current moves around the world. Humidity. Humidity is the amount of water vapor in the air. Water vapor makes clouds and precipitation like rain and snow. Relative humidity is the maximum amount of water vapor that the air can hold at a certain temperature. In other words, the relative humidity changes based on how hot or how cold the atmosphere is at a certain time at a certain place. To give you a quick hint on how this works, warm air will hold way more water vapor than cold air. And if you have questions about that, shoot me an email. I'd love to explain. To see humidity in action, one way we can see this is with precipitation like rain or sleet or hail or snow. But also, if you've seen The Incredibles, Frozone uses the humidity or moisture in the air to make his ice. Precipitation. Rain, hail, and snow are examples of water falling from the sky. This is precipitation. When the relative humidity we talked about, or the maximum amount of water vapor the air can hold at a certain temperature, reaches 100%, we can say that air is saturated and cannot hold any more water vapor. When this happens, clouds and precipitation will form when air cools below its saturation point. Weather systems. Weather systems are moving warm and cold air on our planet. These patterns of air are known as high pressure systems and low pressure systems. Remember, we mentioned these and how they work when we talked about pressure systems. A quick reminder, the picture at the bottom of your screen shows both a high and a low pressure system. Remember, in a high pressure system, densely, tightly packed air moves down from high up in the atmosphere and spreads out. When this happens, we have clear skies. The opposite is true for a low pressure system. In a low pressure system, there is not densely packed air, and as a result, outside air swirls to the middle of the low pressure system and rises into the atmosphere. When this happens, the air cools down and we can normally expect clouds and precipitation. Air masses and fronts. There are different kinds of air masses, or enormous bodies of air, and they're characterized by where they form. The picture on your screen shows several different kinds of air masses. The words that describe air masses are continental and maritime, as well as tropical and polar. A continental air mass, shown here in orange and dark blue, indicate air masses that are formed above land, or continents. These air masses are generally more dry. Maritime air masses, shown here in green and light blue, are formed over oceans. These air masses are generally more wet. In addition to continental and maritime we can also describe air masses based on their temperature. Here, the green and orange air masses are tropical, meaning they're formed near the tropics and they're a lot warmer. The other temperature we use to describe air masses is polar, so close to the poles. Here, the light and dark blue air masses are polar and will have cold air. When we talk about fronts, we're talking about air masses that are meeting each other. Based on which type of air mass is moving, that is how we classify the front. The picture on the left shows a cold front because the cold air is moving forward and pushing this warm air out of the way. On the right side, we have the opposite, a warm front. The warm air is pushing the cold air out of the way. Notice that warm air rises. So in a cold front, the cold air moves underneath the warm air. In a warm front, the warm air pushes the cold air and still rises above. Here's a picture of some air masses. Again, we have a cold air mass pushing warm air out of the way. A warm front, where warm air pushes slowly over a cold air mass. And finally, a stationary front, where neither the cold air nor the warm air are moving. We show fronts in a few different ways. A warm front is shown with a red line and semicircles. We can remember this as a warm front because it kind of looks like the sun. A cold front is shown with a blue line and triangles. When this is upside down, we can remember it's cold because it looks like icicles. Finally, a stationary front shows traits of cold and warm air fronts. A stationary front shows traits of both cold fronts and warm fronts. Check out this website I've linked. It's an excellent way that shows how fronts move, and you can be in charge of what kind of front and how quickly it moves on the website. Finally, if you've got some time and want to explore extreme weather, check out this tornado video. It's about an hour long, and normally it's a regular day of class. Check it out if you have time. Finally, Ms. Bracher put together a couple of extreme weather videos. We've got hurricanes, tornadoes, and I think a blizzard too. These videos are all linked in the attached slideshow. As always, if you have any questions, need help, or anything else, please contact me via Remind or an email. I'm always here to help.